will come the flow. So consider a situation where my mobile phone is switched off and I'm turning on my mobile to make a call. So what is the first thing a mobile phone should do? To find the nearest cell phone tower. So let's consider I'm the cell phone. So how do I know where is the nearest cell phone tower? I don't have eyes. Now I need to act like a bat. Listen carefully to the information that I've been receiving by my antenna. So, considering the environment, a phone receives a lot of signals in it. And I need to find a particular information that tells me the location of the nearest cell phone tower. Then I get to synchronize with it. Thus, my signal strength is increased or decreased based on the situation. Now, let's come to the particular information part. This information in 5G is called SSV, Synchronization Signal Block. Since it is called as a block, it has a standardized structure like 4 OFDM symbol and 240 subcarrier. So this is a known structure that is fed into every mobile phone, every 5G mobile phone during manufacturing. The SSB is transmitted by the radio tower periodically. Even if your user equipment is receiving or not, a radio tower transmits the signal in a periodic manner with a particular gap in between, which we will see in the MATLAB video. When a mobile phone captures the signal, the decoding process started. So before going to decoding, let's see what's the outcome. So why do I need to decode this? So one, we know using the SSB decoding we need to find the location of the cell phone tower, but also using this SSB information, a cell phone fixes its time and frequency with respect to the radio tower for further communication. After this, the guy might take a cell phone, turn on his mobile data, doom scroll, or whatever. So that is used to also find the PCI, physical cell ID, which is the cell ID for the radio tower. We don't actually need a actual definition, but still. Now let's come to the technical part. So in SSB, there are just three main components. One is called PSS, physical synchronization signal, and second is yes, secondary synchronization signal, and third one is PBCH, physical broadcast channel. So these three may you might also seen that one in this a format. So this is how the format of these three particular components is situated in the SSB. So as a whole, it's called SSB. So let's come to the first part, which is PSS. So when UE receives a signal, just as I told, SSB is already being fed into every mobile phones. So with a known PSS sequence, a mobile phone correlates with the received PSS and finds the information. So correlation is a process where a received signal is being correlated with another signal. It's more like a, you can see like correlation is more like a multiplication process where we can find the differences in the signal so we get the information out of it. So this info is called NID2. So it has a three possible PSS sequence. So just keep this in mind, it will make sense later. So now let's go to the second part. SSS. So just as before, the same processes happen with the known SSS sequence. The signal is correlated with the received SSS signal and gives the info. This info is called NID. So it is a list of possible cells, 355 here for example. So that PCI, to find the PCI, we use just both PSS and SSS. So the total NID is equal to NID 2 cross NID 1. So just a simple map. So 3 cross 3, 36, which is equal to 1008. Total cells. Wait. So what is a cell? Cell. Cell. So I hope you understand. Now let's come to the final part, which is PBCH, physical broadcast channel. So this is the one of the important data that contains the information about MIB, master information block. You can also, I mean, the name suggests it's a master information block. It has the information about the system. Our system in sense the radio tower. Everybody. So let's give a generic formula and let's see how PBCH is found. So let's consider the received signal as y of k, which is equal to h of k dot x of k plus w of k. So let's remove this guy because it's just an echo or noise or just interference or whatever. So we don't want this guy. So we need to consider this peculiar formula where this is the received signal by the antenna and this is the channel response and this is our PBCH. So how do I find the x of k? Simple. We use something called DMRS, demodulation response signaling. So using this, we got to find the h cap of k and then we use this h cap of k to find the x of k. We don't need the math behind it. We just need to understand like this is happening. So naming the terms, this is called channel estimation. And x of k is just a formula of y of k divided by h cap of k. So here we get the PBCH. So this is how the decoding process of SSB is done. So let us come to let us just revise. So this is how the decoding process is done. So now we have the MIV information, PCI, and using these two we can easily connect with the radio tower, and our signal strength is increased or decreased, of course. So SSB is just this packet format which contains PSS, SSS, and PBCH. So using PSS we got NID 2, and using SSS we got NID 1. Using this both information we got to find the PSI, which is NID. This is the formula and we get this one. So then we got to find the PBCH, where we have the master information block. And using this basic idea, you might understand how we receive the signal, right? So in next video, I will be doing the MATLAB simulation for the same thing what I just shown you. So you might understand this even better. So this is the theoretical part of the video, and I hope you understand. If you have any doubts or anything, you can just comment down below. Thank you.